Hey guys, this is question MM088 of the Maths Methods Sharpen Study Guide. Excuse me, so we've got a graph f of x equals -2 times x take 2 squared plus 1, where x is an element between 3 on 2 and 7 on 2. And the graph is shown below here. The graph intersects the x-axis at point P. Cool, so I'm just going to remove this bit of paper here so that we can work properly. And we've got this section here. All right, and what the question wants us to do first is find the coordinates of point P. So as the question said, the graph intersects the x-axis at point P. So point P is simply an x-intercept. It's a 1 mark question, so should be fairly straightforward. How do we find x-intercept? We let y equals 0. So for x int y equals 0, which means that 0 equals -2 x take 2 squared plus 1. So what's our first step? We take 1 to the other side, get -1, and then we divide both sides by -2 equals x take 2 squared. We square root both sides and we get x take 2 equals the square root of 1/2 plus minus. Always remember this plus minus. That is extremely important. So then from here, x equals 2 plus minus square root of 1/2, which means that you get x equals 2 plus 1 on root 2, and x equals 2 minus 1 on root 2. Now, what we're looking for is this point P. Now, we have to decide which x-intercept we're going to use, because normally there would be 2 x-intercepts, but because of the restricted domain up here, there's only the 1 at P. We can see that the middle of the turning point occurs at x equals 2, and P is greater than 2, which means that our x-intercept has to be 2 plus 1 on root 2. So therefore, point P equals 2 plus 1 on root 2, which is actually equal to root 2 on 2. And the reason why is because if we rationalize our denominator, what that means is we multiply by root 2 on root 2, which isn't actually changing the number, we're just multiplying by 1, but changing the fraction. And then that equals root 2 over root 2 times root 2, which is just 2. So it's root 2 on 2, 0. And that's our final answer. Now it's a 1 mark question, like I said, so all you need to do is write this. Awesome. That's question A done. So on to question BI. So we've got the following sequence of transformations is applied to the graph of f of x to create the graph of g of x. A translation of 1 unit in the negative x-axis, translation of 2 units in the negative y-axis, and then a reflection over the y-axis. On the axes below, sketch the graph of g of x, label the endpoints with their coordinates. So we've got an axis here that we need to draw this graph of g of x on. So what I'm actually going to do is draw a couple of sketches first, and this is exactly what I would do in the actual exam if I was doing this question. And I would start by just simply redrawing the original graph. So we've got from here to here, this is at 3 on 2, this is at 7 on 2. And you'd actually need to work out the coordinates of this point, which would actually equal 1/2 and -7 over 2. Okay, cool. So now that we've got the original graph drawn, we've got this sketch here. And what we want to do is just apply these translations as we go. So if we applied a translation of 1 unit in the negative x-axis, we'd be moving it left by 1, which would mean that this would be moved across 1, which means this new coordinate would be 5 on 2 and still the same y coordinate. And this coordinate would be 1/2 and still 1/2 because we've moved it negative one unit. So 3 on 2 take away 1 is 1/2. Then what would happen if we translated this graph 2 units in the negative y-axis? So from here, in the negative y-axis, we would have the x values would stay the same, and we'd have 1/2 take away 2, which is negative 3 on 2. So we'd have this to here, which would be 1/2 negative 3 on 2. And here would be 5 on 2 take away 2, which is 1 on 2. Oh, sorry, 5 on 2. And then negative 7 on 2 take away 2. So that would be negative 11 on 2. If we were to then translate this by a reflection over the y-axis, what that would actually do is change all the x values to the opposite sign. So here, this would turn into negative 1/2 and the y would stay the same. So we'd have negative 1/2 and negative 3 on 2. And then we'd have negative 5 on 2 and negative 11 on 2. So it would look something like this. And this turning point here would be negative 1, negative 1. Awesome. So this is our final graph. And what we actually need to do is now sketch that on the axis. So we've got negative 1/2, negative 3 on 2. So we've got negative 1/2, negative 3 on 2, which is here. What we then have is negative 1, negative 1 as the turning point, which is here. And we then have negative 5 on 2, negative 11 on 2 as the final point, as you can see on this graph here. So we've got negative 5 on 2, which is negative 2.5, and then negative 11 on 2, which is negative 5.5, which is down here. Which means that our final graph would look something like this. And we have to label all endpoints with their coordinates. So this is negative 5 on 2, negative 11 on 2. This is negative 1/2, negative 3 on 2. And I like to label the turning point as well, just for safety. But that's it. That's how we would do this question. And it's worth 3 marks. As with all graphs, they sort of give you all the marks to start with and then take away what they can based on what you didn't include. So we've included all the endpoints, we've included the negative 1 to negative 1, and that's all we need to do. So now what we need to do is actually come up with an equation for g of x. So the way that we do that is we use a transformation matrix. So I prefer to use a transformation matrix. Or if you are not comfortable with that, I would just actually apply the translations normally. So the way that we do that is we know that there's a translation of 1 unit in the negative x-axis. Let's start by writing the original function. So the original function f of x is equal to negative 2 x take 2 squared plus 1. Now a translation of 1 unit in the negative x-axis, this part here in the equation represents our horizontal translation. So if we're translating it 1 unit in the negative direction, that means that we have to add 1 in here, which means that we have to take away 2 plus 1 squared plus 1, which gives us negative 2 x take 1 squared plus 1. Now this is our horizontal translation. Then a translation of 2 units in the negative y-axis means that we have to minus 2 off the end here. So we get negative 2 x take 1 squared plus 1 minus 2, which is negative 2 x take 1 squared take away 1. And that's our vertical translation. And then what we have to do is the reflection over the y-axis, which means that we actually make x a negative. So what happens is we get negative 2, negative x take 1 squared, take away 1. And that's our reflection. So now what we need to do is read the question, because the rule for g of x can be expressed in the form ax squared plus bx plus c, and we need to find the values of a, b, and c. However, at the moment, it is not in that form. So what we need to do is actually change that. So the way that we do that is by expanding everything out. So negative x times negative x is x squared. Negative x times negative 1 is x. Times that by 2 is positive 2x. And then negative 1 times negative 1 is positive 1. Take away 1. So then from here, we expand all this out and we get negative 2x squared, take 4x, take 2, take away 1, which gives negative 2x squared, take 4x, take 3, which means that a equals negative 2, b equals negative 4, c equals negative 3. And that is our final answer. Now for this question, state the domain of g of x. All we need to do is look back at the graph that we just sketched before, and we can see, and this is just a 1 mark question, so all we need to do is state it. Our domain is, so I'd say dom g of x equals negative 5 on 2 to negative 1 half.